Good evening. This is T.S.Aditya from BTech ECE second year, and I'm here to present about the idea of swarm robots which operate using the human gesture control. So basically, what my idea about is that during disaster management, the firefighters and the rescue people put their lives on risk, and then go to those disaster places and save the others' lives. But then what happens is that during most of the cases, the firefighters and the rescue workers themselves find themselves at risk. So I'm trying to avoid that by using robotics, and robotics will help in the way that I will be using swarm robotics, in the sense more than three numbers of robots will go into the building and check where the fatalities has occurred, and where the people are there, so that they can exactly know the location of the people who are struggling, so that after getting the information, the firefighters can easily go over there and then carry them and then evacuate the place as soon as possible. So I would like to demonstrate this idea using a couple of video links that I have found. So this one is about self-organizing systems. This research was carried by the Harvard University. Over here they have used very tiny robots which assemble themselves and communicate within themselves to know where each and every one of them is, and then accordingly they will self-organize themselves. So complex algorithms have been run on these particular robots, so that they are aware of each other, and then they can work in coordination. So as the old saying says, unity is strength and divided we fall. Similarly, we are trying to accomplish more work using more than two numbers of robots. And over here we can see that the LEDs, the color of the LEDs change when the distance of the two robots change. So similarly, they communicate between themselves using wireless transmission, and they are able to know where each and every robot is. So this is basically they have used the self-assembly algorithm. So using similar stuff, the robots can know that the robots can assign each and every one of them a particular room. Say in a building that a fire has been caught, so one robot can be assigned to the bedroom and the one robot can be assigned to the kitchen, and then they can communicate between themselves and know what has happened in which place, and then communicate it to the user who is directly using it. So these are the three primitive behaviors and the analysis they have done during the research. So let's please take a look at the example of how they work. They communicate between each other, and that's why they are stopping in between. Similarly, this is based on ground. Now let us take another example of quadcopters which use self-assembling algorithms in the same way. Here they are using more than three numbers of quadcopters, and using that they are able to organize themselves and communicate between themselves, and henceforth are able to organize are in a much organized way. So we can see that those two robots are able to coordinate between themselves and move between each other places. So basically it's an interconnection of networks, and hence they are able to communicate and then process more tasks at the same time. So similarly, as I had explained about the trajectory planning, in the way that they can go to one of the rooms and divide the work between themselves, so that the work has been completed earlier. Complex trajectory plannings have been evolved over here. As we can see that over here, that the robots are able to plan according to themselves very beautifully. Okay, so we have seen how these robots actually perform. So what happens in an actual disaster scenario? Let's see. And over here we have taken the same quadcopter concept, and over here we have used 4 quadcopters. In this simulation particularly, they have used 4 quadcopters, and they have simulated various events of various disastrous events. And so each and every quadcopters are using some scanning material or cameras by chance itself, and then we can see those feedbacks in the right side of the screen. so they are able to realize where the fire has been there, and so they are able to recognize what is happening over where, and immediately they are reported back to the user. And in the same way, they are able to scan a larger area in a very efficient manner, and hence a lot of time is saved. And over here we can see that a person has been injured over here, so the quadcopter is easily able to identify that and then report it back to the user. If not for these quadcopters, it would have taken a large amount of time for themselves to actually go over there. So but during these such critical conditions, time is a very essential matter, so we are able to save a lot of time over here by dividing the work and then making it a more efficient process. So similarly, a master and a master slave method is used over here, in which the green color bot resembles actually a medical kit. So after these three robots go over there and recognize where the particular where the emergency is, the other robots goes over there and then is able to help with the help of the first aid kit. Okay, so this is one of the applications. What about the other applications that this can handle? The other one is army, because as we know, tiny and small robots actually form a large part of the army for spying and stuff. But then in a similar way, here they are using a large number of robots, especially to destroy tanks. So we will see over here they are using robots that are being deployed by using the cargo planes, and let's see what happens. They are deployed through air, and then using parachute they are laid down. So in a smart way, it is able to track back the parachute also along with itself, and then it also deploys a camouflaging apparatus. And so over here there are a lot of, this is not the only robot that is being deployed. As we had seen earlier, there were a lot number of robots that was being deployed. So similarly, all the other robots do the same work, and then when it's deployed, let's see what happens. The camouflaging technique doesn't even allow the enemies to see where it actually is. So this is one of the enemies drone, and it is making sure that there are no dangers, especially over here. And see, after the tanks have come, it is able to shoot accordingly, and the tanks are also not able to know where the enemies actually are. So in a similar way, there are a large number of robots that are placed over there, and then they coordinate between themselves and see where more number of tanks are coming in and are able to shoot them accordingly. So these are the various applications of this idea that can be used. Swarm robotics has been a very interesting area of research recently, but hasn't been exploited properly enough to make it more commercial. So over here, as I had explained earlier, this is a gesture recognition based design. I've used this because for the ease of user interface, and it also uses a Myo band to actually know what kind of gestures are being made. So thank you.